All right guys, welcome to another Build Insight. I'm on site this morning with the Piper Leaker team. We're doing a site set out, we're doing a survey on one of our projects here. The guys are just setting up the equipment in the background here. We've got a few different reference points around on block corners, street corners and things like that to get the initial reading for where the existing building should actually be on the block. We're gonna go around and show you how we do a site set out to make sure that we've got our new addition in exactly the right spot.
I'm a surveyor, and these are our little retroreflective stickers that we use as survey control points. You'll often see them around on streets, on Stoby poles and heavy structures that aren't going to move. And they're like a non-destructive survey mark that we can put in that doesn't bother anyone and get in anyone's way. So we use these to go and help lock in our positioning for our instruments so we know where we are. We often tuck these up nice and high out of the way and on nice flat smooth surfaces. And then that way it doesn't bother anyone.
Right, so if you come in here, this is an example of one of the original survey markers. So typically you would see these little plates in the footpath and things like that, that normally you'd see like a pipe or something underneath it, but this is actually one of the original brass plates. It's a little bit dirty, but it's got do not move on there, and a triangle is the original survey point. This will relay back over to where the guys are setting out on the corner behind me and trying to get two separate points to try and identify one starting point from the block, and then they'll work into the yard from there.
Okay, so at the moment we're doing what's called traversing with our total station, and it's a way of moving our position and keeping our accurate location as we're going. So what we're going to do is this theodolite goes and takes an observation to the point down the road, and then we acknowledge that every instrument is always going to have a small amount of error in it, and because of that we do what's called changing face with our instrument, so it turns around. And so that way the error is now in the equal opposite direction. A very small one, but this goes and helps make sure that we're exactly where we need to be. So now that we've gone and got that observation, I now know where that mark is up in the driveway up the road. And now I'll go and disconnect the total station. And this is called constrained centering. So now this just unclips out of here gently. Lift that out careful, and now I can move this up the road, and now I know exactly where I am as we're going. So now we're going to go and disconnect this one that we've just taken observation to, and pass that one on. Now this one will discreetly lock into here. Now lock that back into place, and now we know exactly where we are to the millimetre. So that's how traversing works. So I'll do a little move on that, and you see that really hasn't changed any position at all.
So it's been a bit of a process. The guys have gone and they've marked all the corners. Now we're in the middle of the driveway. John's just set up the tripod in the middle of the yard for us, so we're making our way into the property. The little yellow stickers that Daniel put up earlier, what he's doing now is going along and logging all of those points to now actually start to reference where the existing building is. So what we've got going on here is Daniel has the tripod and referencing back to the little stickers, the points that we had on the back corners of the wall, and this is going around and now actually logging it on the map so they can begin to mark out where the existing structure is, and then we'll go through and mark out the back section on where the new addition's going to be.
Point stored. Our surveying field office. It's a room with a view. And just looking over our data that we've collected now. So now I've got to go and process what looks like the matrix data and get that into usable information. So for people that don't know, this is our point identifier, our horizontal angle, our vertical angle, our slope distance, our prism constants, and then these are coordinate information that's stored with it as well. So we process all of this through some particular surveying package, and then we can accurately determine where all of the existing building is, and then we'll use that to bring in the new design to match onto it as best as we possibly can.
All right, now we're up to the exciting part. So Daniel's just done the model on the computer with all the data that they've collected from this morning, and then overlaid the plans for the new addition onto it, taken the data from the computer, plugged it into the controller for the theodolite, and now the exciting part is to get to go around and start actually marking out with the pins where the new corners of the building is going to be. Okay, so now Daniel's gone around and he's logged all of these points from the model that he's created with their staff. And what it is these little metal pins that go in the ground here. So this is the exact point. They tie a ribbon onto it so that you actually know where it is. And then next to it is a peg that tells you what it is and what the offset might actually be. So what these two are here that we've got is to mark out the corner of our building. So this one little pin over this side and this side here, lining those two up with the offsets will actually give us the corner. So if we read this one, what we've got is a 0.7 meter offset to the corner of the building, meaning that if we come back this way, 700 mil is going to be the corner of the building. And then from this one over this side, we've got a 1 meter offset to the building. So back from the pin here, back this way is going to be a meter. So if we come a meter and 700 mil off of those two pins, gives us roughly about there is going to be the back corner of our building. That way that we're not relying on string lines coming down the side of the existing building or anything like that. That could potentially mean that we've got things that are a little bit out of parallel or out of square. Making sure that we've got all of these exact points of the building marked out off of a survey just ensures that absolute accuracy, particularly if you're building on a boundary. Something like this, there isn't any parts of this building that's actually going to be on the boundary, so it's not as crucial, but it's just a simple way just to make sure that you're foolproofing it. Anyone can come on site then, whether they've got the plans or not. Sometimes things on the plans can be a little bit tricky to read, but at least this way is a clear indication so that everyone has the exact points of the building that they need. So over this side, we've got a few more pins over here. So we've got quite a few pegs. We've got 1, 2, 3, 4, 5 pegs over here. You can kind of see a little bit of the pink line and the blue lines that I've actually spray painted on the ground here. There's a bit of a step in the building here. So just making sure, there we go. We've also got a reference just on the brick wall that the guys have marked there as well, just to make sure that the steps in the building, everything like that, everything's parallel, nice and square, and the building can be set out completely accurate. All right guys, there you go. So that's a brief on how we start a project and set out to make sure that everything's in the right spot. As you can see, quite a process ensuring that all of the original pins are surveyed and marked out properly before we overlay the new building. Hope you've enjoyed it. We'll catch you on the next one.